Hello and welcome to our today's meetup. We have a very
Hi, everyone.
interesting topic today. It's about GraphQL, and we have Michael Steib as speaker. So welcome, Michael.
Hi, everyone.
Before we start, please someone write something to the chat so that we know that you're hearing us. That would be great. Not that we start without our audience. So let's wait for a second.
Okay, let me type hi.
Yes, perfect.
Thank you.
Great, seems it works. Good. Before we start, I have a few slides before the presentation. So let me start here. So first of all, our friends at Microsoft asked to let you know about a current offer. It's the Microsoft Spring Skills Challenge, and it's possible to get this nice looking backpack. Oh, this was too fast. So you can open this URL, aka.ms/spring-skills-at, and you will come to this website where you get where you can see all the details about it. Basically, it's about doing some certifications. You can choose one of the listed certifications here, and then if you completed it, you can send a mail to springchallenge@microsoft.com, and you will get the instructions how you can receive the backpack. There are also some details here about the whole challenge. So it's limited to some countries. Please check first if you're eligible to join this challenge. Good, that's the first thing I wanted to mention. So again, the URL for everyone, we can also post it later to the chat. So again, aka.ms/spring-skills-at. Good, and the second thing I want to mention, it's the Global Azure Austria event. So previously it was called Global Azure Bootcamp. Now it's just Global Azure Austria, and it will take place on the 6th of May in this year. It's a one-day event. It's online again because of the COVID situation. Also, there is a website for the Global Azure Austria event, and you can see speakers, sessions, and everything on this page. There are some talks from Microsoft, but it's mainly from the community. And of course, as the name says, it's about different topics in Azure. So I can highly recommend this event. It was very great every year, and there are already some interesting sessions and speakers. So yeah, check it out. It's just globalazure.at is the website. Good. That's basically it from my side. If you have any questions or ideas for a talk, you can contact us, Igor or me. And yeah, that's it from the introduction.
Yeah. From my side, as always, most of you already know how it goes. So Michael will give us a presentation, and please type your questions into the comments, and we will have a Q&A session after the talk. So as always, so I think that's it. Yeah, Michael, the stage is yours.
Yeah, thank you. Let me just fire up my screen. Okay, I'm Michael Steib. I'm a Microsoft MVP, and I'm also a GraphQL TSC, meaning one of the guys that have voting rights on the spec. And apart from these, I have written one of the two largest GraphQL implementations in .NET, which is called Hot Chocolate. And we will take a trip together today to explore what GraphQL is, and also how we can build GraphQL servers in .NET. So I redone my slides and all my talk, so it's the first time that I give it in that version, so it might be some hiccups, but let's get started. So when exploring GraphQL, people in the .NET community often start with what is GraphQL? But it's more, I think in the beginning, we should actually ask, why GraphQL? So why was GraphQL created? And what was the reasoning behind it? And who created it? So actually, GraphQL was created by Facebook. And today they are called Meta. But they created it for a specific purpose back then. And that was for their mobile applications. So back in 2011, 2012, Facebook came out with their first mobile applications. And back then, people were quite upset about the applications because they had very slow startup times. They were really laggy to use. And on top of that, they used a lot of data. So when you just used a bit of Facebook, did some messages, it quickly burned through your data plans. And it also started to drain your batteries. So Facebook was facing a lot of criticism back then and put together an engineering team that started to look into the problems that the Facebook app back then had. And actually, Facebook did nothing wrong here. They did what they knew and took all the technologies that they used in the backend to build mobile applications, which is HTML, and they used REST for communication between their backend and front end and stuff like that. But when they looked at the problems they had about slow startup times, high data usage, and stuff like that, they actually discovered that using standard web technologies that they used on the desktop for browsing their Facebook page was actually the issue. So when they started, for instance, the web application, their mobile application, they discovered that they already had a couple of hundred requests just to start up the Facebook application. And that was because they used a very clean REST endpoint. And it's actually called the Facebook graph. And the Facebook graph is actually not GraphQL back then. It's a REST API. And it's quite well-formed. So, for instance, they fetched at the beginning of the application, they fetched the currently signed in user. They get a response back, JSON typically, and they essentially got all the properties for their user back. But then they need to get some stories and some news, some comments, some friend list for the user. So they have to grab here the user ID from the user, pass it into another request, and, for instance, get the news. And then when they essentially get a list of news here, they again have to take some IDs from that request and pass it to the next request to get the comments, for instance. And you can already see where this leads, because in REST we have this concept of resources, where each resource essentially has its own endpoint. For instance, comments has a comments endpoint, users has a users endpoint, and so on. We kind of, this is one of the features in REST where we have these resources and scale also along these resources. But it also means we have these closed silos. And if we need more or less information, we always have to do more requests than we actually want to. And also with REST, we have to consume what this resource gives us. We have no way of telling the endpoint that we want more or less data. Sure, there are things like sparse data, but that's not the point that I want to make. So if we would look at such a at our requests from a graph standpoint, we would look at something that we would call cascading requests, where we have a request that wait of other requests. So essentially, we have to do some requests to acquire some data to do the next request. It's kind of like waves, where you get some data and then generate from that the next requests, and get this data again, get some more requests. We also call that the N+1 problem, where we have over or under fetching, or in this case, actually both together. So when we do the first request to fetch the user, we might have overfetching because we get all the information about our user. We also have underfetching because we don't get enough data. We get all the data that this endpoints gives us, but we also don't get enough data because we would need the comments and the user information that may be commented on news feeds, on our newsfeed, and so on. So back in 2012, Facebook took this analyzed problem and they started a new project to solve it. They called it Supergraph. This is actually 10 years ago. So when you think about GraphQL, you always think about this new kid on the block, this new technology, but Facebook actually used it already. This is the commit when Facebook committed to their system the first usable version of GraphQL. And that was in March 2012. So it's 10 years ago. So fast forward, in 2016 was when Facebook finally released GraphQL as an open source specification. And that's where the open source community could pick up GraphQL and finally start using it. So what is GraphQL? I haven't answered this question so far. Before I answer it, let's have a look at GraphQL and explore how it solves the problems that I depicted earlier. So this is a simple GraphQL query. You could say it's the hello world of GraphQL. In this GraphQL query, I'm asking for the currently signed in user, and from this currently signed in user, just for the name. If I send that to my GraphQL server, I get back a response that closely aligns my request. Some people mistake the query actually for an empty JSON graph. It's not, but it kind of looks the same. So you could have this mental picture of sending an empty JSON graph into the backend, and the backend just fills it up with data and sends it back. But GraphQL is not only about just a simple sparse fields where you can essentially define, okay, for me, I need the name field or the ID field. It's actually about trees of data. And as my components or my use cases change, I just can change my request to ask for more or less data. And that is a complete new dynamic that they created. Think about it. With a REST request, or with REST as your backend, you always had to change the backend if you had new, you needed new shapes of data. Like if you, for instance, needed more or less data, you need to optimize your request in the backend or create new resources in the backend to get that data. In GraphQL, you just change your request and maybe ask for the profile picture of that user and some attributes about that profile picture. And again, if you send that to your backend, to your GraphQL backend, it will fulfill that request. So I said GraphQL is not only about flat data structures like that we can ask for direct fields of me. And we could say image still is something from the user. But actually, GraphQL is about trees of data. I think the name graph in GraphQL already said it. It's about trees. So we can drill into related data. For instance, if we stay with the example of the Facebook page, we could, in one request, ask the backend for the currently signed in user, and in this case for the name and maybe the date and time when the last time was we logged in. And we want the same data for our friends. So we want to fetch the currently signed in user and the friends of this currently signed in user. And we could send that to our server, and we would get a nice response here that closely aligns our request. But we already can see that we have some repetition here. Name and last seen is declared multiple times. Me returns actually a user object, and friends a list of users. So in GraphQL, we actually have a construct called a fragment. And a fragment is our primitive for composition. It allows us to compose fragment hierarchies as we compose component hierarchies in the front end and class hierarchies in our backends. And what you can do with that is essentially describing the data requirements for your UI components. So person info, there could be a component person info, and with a fragment you actually describe the data requirements of your component in the front end. So if you think about it, GraphQL reverses how we used to interact with our backends. Instead of the backend engineer telling us how a certain resource works, what we can consume and what we can do, it's now the front-end developer or the consumer of the API that tells the backend what he or she needs. So we can tell the backend that we need the username from the currently signed in user and nothing more. And the backend will honor that and just send this data down. We also can drill into related data, as we saw, and thus save round trips. We don't have to do multiple requests. We can just put everything in one request and ask exactly for the data that we need in a specific moment of time or in a specific use case. So what is GraphQL? If you look at the GraphQL specification, GraphQL is a query language for your API. It's not a query language for the database, and it's not a query language in the traditional sense like SQL, where you compose of different tables and stuff, your request for the database. It's more like diving into an API and selecting from the API that the backend exposes the things that you need. And we will see that as we dive in deeper into some demos. GraphQL is also a runtime to fulfill these queries. With GraphQL, we have a single endpoint. We don't have like these thousands of endpoints that we have with REST. We just have a single endpoint because we are crafting the GraphQL query. We are crafting what we need. So we can fetch everything that we need in a certain component, in a certain use case, or at one specific point in time in one request, saving on round trips. And most importantly, we never over or under fetch because we tell the server exactly what we need and the server can gather it up together. There might be over or under fetching in our backend, but that is not our problem actually. Because the expensive thing is sending the data down to the consumer. If we have for instance, overfetching between our GraphQL layer and the backend service, that's not so problematic. We still can solve that with GraphQL in the backend, but it's not the problematic part, because in the backend we have unlimited bandwidth. It's not unlimited, but potentially unlimited bandwidth, whereas our consumer could sit in a bus with a 3G connection. So we don't want to send anything down that we don't need, and we don't want to do any requests that we don't have to do. GraphQL is built on a strong type system, and that's a great thing because we can trust our execution engine. So when people start thinking about GraphQL, they say, okay, we also have schemas with REST. We also have type declarations with REST. If we use the Open API specification, for instance. Yeah, that's true. But actually, that's just a schema document. There's no enforcement. Like if you tell the consumer in your schema that you're never sending null for a certain field down, or that a certain field is a string, and you still send an int down, there's nothing that will stop you. Because in the Open API specification, it's just a schema document. But in GraphQL, that is actually a runtime that will enforce your type system. So if you violate that, if the backend would return null for a non-null field, the GraphQL runtime would actually throw an error and say tell the client that something went wrong in the backend and we cannot give you that response because it's broken, because you wanted to send something down that didn't align with what you said you would send down. And that makes GraphQL predictable to use for the backend engineer as well as for the front-end engineer, because the front-end engineer actually can trust if you say something is nullable that it might send null down. And if you say something is non-nullable or something is an int or a string, you can trust that this will in fact always be a string or never be null. On top of that, GraphQL is real time. There are solutions in REST for that. There are also solutions in gRPC and stuff like that for that. But in GraphQL, it's just baked in. And we will have a look actually at all these capabilities today. So let's have a look at our first demo. And for that, I'm starting here a GraphQL IDE. It's called Banana Cake Pop, and it's actually done by our project. So the Chili Cream project is not only building GraphQL, the GraphQL.NET server, Hot Chocolate, but we're also building this tool here, for instance, to explore GraphQL endpoints. And there are other tools that we build. So it's a quite round project. So what I want to explore today is actually a simple API. Let me just clone this document and get rid of that. So I opened here now a GraphQL endpoint, this crypto workshop, .chillicream.com. It's one of our new workshops that we do actually. And we want to just explore a bit what GraphQL is further and get a feel for it. So I opened this endpoint here. And what I can do with GraphQL is first explore what this endpoint offers to me. So I can go here to this tab schema reference and see that I actually have here 3 root types called query, mutation, and subscription. For now, we will just look at query. We will explore mutation and subscription down the road. Let me actually switch the view here and explore it from a different angle. So what we want to look at here is the query type. A query in GraphQL is what the GET request is in REST. It's essentially reading data. But GraphQL specifies more what it actually means. In GraphQL, a query is side effect-free read on your data system. So there is no mutating the data while you're reading from that. We go into that more deeply as we progress in the talk. So I can see that I have a couple of fields here. So I have a me, I have a get assets by ID, and I have a field get assets here. Let's explore get assets by symbol, for instance. Get asset by symbol will get a crypto coin by its symbol. For instance, I can pass in, let's have a look. I can pass in the symbol, which could be the BTC for Bitcoin or ETH for Ethereum and stuff like that. And then I would get back an asset. You can see here all the fields that I have on the asset, like name, is it in my watch list? Maybe does it have a color in my UI? Or does it have an image? I could drill into the price information. In the price information, I can see there are lots of data points, like what is a change in 24 hours, like a percentage change in the last 24 hours, what was the high in the last 24 hours, and so on. I could also drill in further, go in the historic data of my coin, and so forth. Okay, so I can easily discover what my schema actually offers to me before I do the first request to it. And that's one pretty good thing, and that is essentially powered by our data type system that we have beneath our GraphQL implementation. The important piece here is, like when I explained these GraphQL queries in the beginning, so you can essentially tell the backend what you want. You cannot just ask for anything. A GraphQL schema actually has to expose it, and then you can pick from that. So if there weren't a me field here, I couldn't ask for the me field. Okay, so it's not an arbitrary query language like SQL, where I essentially can ask for everything that is there, but it's more I can pick from an API. So you're building your API with all the capabilities that you have in .NET or in any other language, and we can put a thin layer of GraphQL over it and make it accessible. Let's explore it a bit. So let's write a simple query here. A query in GraphQL starts with a keyword query, and then I can drill in and ask for fields. You can see IntelliSense is kicking in, and in this case, I want to get the asset by ID, and from this by symbol, and from this asset, I want to have the name, and maybe I want to get the price, the latest price, and let's just leave it by that. Let's just do a very simple query, and then I want to fill in the symbol that I have actually to request the data. So what I can see here is that these things we call fields in GraphQL, and in GraphQL fields are more like a method in .NET. You can see we have arguments here, or we could have arguments. Not every field has an argument. Okay, let's fire that up. If I fire that up, I get, as I showed before, a result that closely aligns with my request. So I don't get anything more than I asked for. That's awesome. But we can actually do a bit more here. Like in GraphQL, this is a single request. But in GraphQL, I also can specify what data means more to me. Like let's say we have parts of our data, and now I'm going into some slow data that actually is fetched from a REST endpoint. I don't see that on my GraphQL layer, but let's dive into that. So we are getting like the price changes and the historic price points that I have over the day. So let's get the price here. Sorry. Get the epoch and the price, and actually we want the change span of the month. So all the price points in that month. So this thing here would actually make this request really, really slow. Let's do that. You can see 900 milliseconds. So in GraphQL, you can not only specify what you want, but you can also specify what you want first. Like, for instance, I could say that I actually want the price first in my UI, but I want the more expensive data as it becomes available. So I can put a directive here on that says defer this data point until it becomes available. So we still are doing now one HTTP request, but the result is streamed down to us, and we get the data as it becomes available. Let's do that again. You can see 164 milliseconds until we get our result. You didn't even see, but we also got the price change. But if we look at our log here, we can see that we initially got just this initial data, the price, the latest price. That's what we wanted to have immediately. And then we got a patch on our data. So you can see we are patching here into that path. In price, we want to patch this data as it became available on our backend system. So we essentially have a stream down to until we have all the data. We could have more defers. You can have cascading defers. We essentially could also say this makes no sense because actually once I have the list, deferring these fields makes no sense. But anyway, just to demonstrate that, we could also have cascading defers, and then we would have thousands of patches. Okay, that's just an initial, how does GraphQL feel to be used, and how do we explore a GraphQL endpoint? Let's go back to our slides. So as I said, GraphQL conceptually is a thin layer over our business layer. And we essentially have with GraphQL tooling to expose our business layer without the compromises that we have with REST. With REST, we always had this DTO concept where we have to copy our data into DTOs because we cannot expose our data in a more complex way with interfaces and unions and stuff like that. But in GraphQL, the type system actually has unions, it has enums, it has all the things that you have in .NET. So you can put a thin layer over your business layer and expose it in a much richer way than you were used to with other service technologies. But as GraphQL was open sourced, it also became very popular as a gateway technology, where you might have already a lot of microservices or REST services, gRPC services, OData services, what have you. And you would build this thin layer of GraphQL on top of that. Essentially, with GraphQL, you are now able to model your business layer and model how users should access your business layer. And it's kind of a compensation for all these microservices that you have, and then would be pretty unusable to a user if he had to know, oh, go to this service for this piece of data, go to this service for this piece of data. And you can essentially have this monolith GraphQL, just a thin layer of GraphQL over all your downstream services and makes them accessible in a much nicer way. Okay, so we talked about what GraphQL is. Let's also talk about what GraphQL is not. GraphQL is not a graph database query language. You should have gotten that by now, I hope. And also GraphQL is not bound to a specific data source. So just in my last diagram, we saw that you can put GraphQL over your REST services, you can put GraphQL over your gRPC services, or you can even put GraphQL on top of your business logic. So it's not bound to a data source. And actually, as I said in the beginning, GraphQL is a query language for your API. It's not a GraphQL language for your database. Also, GraphQL is not Facebook's version of OData. There are a lot of differences between OData and GraphQL. The main aspect here you should take is OData was created in the sense from the database up. We had this RIA services back then over WCF, if you remember that. And OData came from this corner of database technologies, whereas GraphQL was built with APIs in mindset. So Facebook had an internal API that they had, their business layer, and they built GraphQL on top of that to let applications more easily access this application layer and actually specify what they need from that application layer. GraphQL is not a good thing for binary streams. Like if you think about Netflix, for instance, streaming movies over GraphQL doesn't work. GraphQL is built for data graphs. So if you have entities, objects, or everything that you can essentially serialize into a graph, that works with GraphQL. But streaming movies over it is not a good thing to do. And although Netflix uses GraphQL in the backend, they're not using it to stream the movies. GraphQL is not limited to HTTP. While we are talking always about REST and GraphQL is actually not limited to HTTP, and GraphQL is by definition transport agnostic. Meaning you can use GraphQL over sockets, and we will see that today. You can also use GraphQL over gRPC. You can use GraphQL over TCP if you want that. TCP sockets. What we do is GraphQL over WebSockets today. But anyway, it's conceptually not bound to HTTP. Also, GraphQL is not limited to the JavaScript world. And that's why I, in the beginning, explained that actually it came from this problem that Facebook had with their mobile applications. The first client for GraphQL was actually written for Java and Swift. So it was not a JavaScript client that they built first. It was a client for Swift and Java. So native mobile applications. That's where it came from. And the first backend was not written in JavaScript. It was actually written in PHP back then at Facebook. So GraphQL exploded in the JavaScript ecosystem because as front-end developers discovered what you can do with GraphQL, it essentially sold itself. You show GraphQL to a front-end developer, they will just, they don't want anything else after that because it empowers them to just build their application and not be dependent on these iterations with the backend engineer anymore. Okay, let's have a look at how GraphQL actually works in a .NET context. And for that, let's actually write some code. Okay, so let's start with a simple hello world. It's the first thing you always do in any language, in any technology. So let's do it in GraphQL. Okay, so I'm using Visual Studio Code, and there's nothing at the moment. The first thing we should do is install the hot chocolate templates, because that simplifies building GraphQL servers. So on the console, you can do .NET new -i and then hot chocolate.templates. And since we use the newest stuff that is not yet stable, but I actually never use stable stuff. Let's go for the preview 15. It's our newest preview that I hope is coming as a stable version in the summer. Okay, so we install our template here. And after that, we are told that there is a GraphQL over Azure Functions template, and there is a GraphQL, the standard GraphQL template. We are using is a standard GraphQL template, which actually is just an ASP.NET Core server with some GraphQL packages in it. Let's create that. .NET new graph. Okay, so that generates our project here. Let me just fix the name here. I didn't specify one, or that demo, and replace all the ugly names. Okay, sorry for that. Let's explore our project a bit. And for that, let me restore it first. .NET restore. Reload that. Okay. So let's first have a look at the project. So our project is a standard .NET ASP.NET Core project. So you can see here we use a standard web SDK. It's essentially you could put web API side by side with GraphQL or anything else that you could do with ASP.NET Core. The main difference here is that we have a couple of packages here. Like here's the ASP.NET Core package, and there's an analyzer for GraphQL in here. And I see I have messed up here a bit, but never mind. Okay, and we are using implicit namespaces here because we use all the new stuff. This is the startup of a GraphQL project. We have essentially the same startup that you would do for web API application, with the difference that you can see that we are declaring GraphQL server in our dependency injection. As I said, the GraphQL server itself is transport agnostic. So it sits here, we're declaring it, and it can be used. And then we have the transport layer. So we are mapping GraphQL actually to our as an HTTP endpoint here. Let me fix that namespace here. And then we have a query type here. You can maybe see in this GraphQL server, we tell it we have a query type, and we explored that in the demo before, that there are 3 root operations. And at the moment, we are only looking at query. Query is our side effect-free reads. And in .NET, a query is a simple class. So you write a simple class, and each of the methods or each of the public properties on this class become fields on your GraphQL endpoint. And you can see there's nothing special here, nothing GraphQL specific. But we can translate that to a GraphQL schema. So in this instance, our query has a field get books. And this is actually not a field. We call that a resolver in the GraphQL context, because that is a method that will get the data, resolve the data for the field book. Okay, let's just start this and see how this class actually translates to GraphQL. let me copy that link. And let's go in a private. So I can just go to my GraphQL endpoint on my .NET server, and you can see that actually we are greeted with Banana Cake Pop, because it's not only an application that I can install on my desktop, it's actually packaged into Hot Chocolate. So whenever you go on the GraphQL route, you will be greeted with this GraphQL IDE, and we can create a new document and then actually explore our API here. And you can see there's a books field. So in GraphQL, we wouldn't have these verbs like get, set in front of our on our fields. So what we do actually is with conventions remove these and GraphQLify them. There are several approaches in GraphQL to specify that more explicitly. I, in general, favor our convention approach, which is using this annotation-based approach here. But you also have a fluent syntax where you can more explicitly define the field name. Anyway, so we have this books field, and we can drill into that and can see that our books actually has an author and a title. And if we go in the author, we actually have a name for the author. If you look at our .NET code here, you can see that we have a book which has a title and an author, and the author has a name. So GraphQL actually can give you the same constructs that you have in .NET. No compromise. Okay, let's query this. Again, we start with query, and then we can drill in. We can see we have a book here. Let's actually fetch only the author name of the book that we have here, execute that, and we get John Skeet. And that is how easy it is actually to build a GraphQL server. Let's customize it a bit. For instance, we want to add a new resolver, a new root field called greetings, which returns a string. So we say that is our greetings resolver. It actually has an argument, name. The default of this argument is Luke. And we return a string, hello name. Right? Very simple thing here. And then let's just restart our server. Go back to our GraphQL IDE. Let's refetch that. Okay, schema was updated. We have a new schema here. Let's have a look. Okay, we can see there's a greetings resolver. We have a name field here, which is a non-nullable string. And we have Luke as the default. That's how powerful this translation is from .NET to GraphQL types. Okay, let's try that out. Actually ask for greetings here. And we get not only the book, but also the greetings field, which is Luke. We could actually ask to meet Michael here. And then it would say, hello, Michael. Okay, very, very basic example of how to create a GraphQL server. Let's dive into a bit more code here. Next example, this is just in-memory data, okay? But I know a lot of the .NET developers have EF Core. So what I show you doesn't work only with Entity Framework. It actually works with MongoDB. It works with anything that you can throw at us. And with version 13, we are also working on integrating. That was one of the biggest user wishes or user asks. We are working on an Elastic integration to even get Elastic data where you can then search over Elastic, but resolve over whatever other data source you want to have. Okay, so this is an empty project here. let's get rid of these temporary files. I have here ChatDB. I don't know why it's called Chat, actually. It's my student DB. There might be a copy-paste issue, but never mind. So what we have here is actually a university DB. Let me just close these guys. Okay. And this example deals with registering students to their courses in the uni. So we have a simple DB context here with 3 entities. We have the course, where we have a title and we have credits, and we are tracking enrollments. In the enrollment, we are tracking actually the grade that a student achieved in a course. A grade is nullable because when he just enrolled, he doesn't have a grade. At the end of the whole thing, he will have a grade. The grade is just an enum with American grades, A, B, C, D, E, F. And we have the student who has a last name, or first or middle name, or first middle name, and an enrollment date. And is also essentially can navigate to the enrollments and so on. So let's put something together to query this data. And again, we are still only doing queries. So let's do a simple query to get the data out of our school context. So the first thing we have done already here is to set up DB context. So we have an add pooled DB context factory here. And that actually just hooks up to our database. So that's already set up. We also set up our GraphQL server here. And at the moment, we just registered our query here. So the first naive thing that we could do is let's allow our system to query the students. So what we would do is essentially expose a variable here of student, and then call that maybe get students. And then we need the DB context. Remember, we have a pooled DB context factory. But we can essentially ask the system to resolve that all for us. We can just say, in our resolver, we need the school context. That's our DB context. And from that context, we will take the students. Okay, very, very simple thing. So in order to inject that here, the right DB context and the right life cycle, we actually have to tell our GraphQL schema a bit about the DB context. So we would go here and say register DB context. And then we tell it that there is a pooled DB context on the dependency injection. Why is that? Oh, I forgot to tell it which DB context. So we just say here there's a register DB context, school context, and it's pooled. And now we actually could just run it. Very naive implementation. It's not actually what we want to stick with. Let me see. Okay. Let's just grab this UI again. New document. Okay. So let's go to our schema reference. We can already see we have students. We have an array here of students, and we can drill in. And we have our whole model already. And we can just explore what this model exposes here. And we already can query that. Let's get, for instance, the last name. and ask for it, and we get all of them. Okay, that's not good, because if it's all the data, we would run out of memory at some point, get into trouble if there's a lot of data in here. But let's deal with that in a second. We also could drill into that, get into enrollment and get the grade, and maybe check out the course. Yeah? Get the course title and the credits. Okay, and run that, and it's empty. So why is that? Because at the moment, what we do is essentially just fetch everything of student, because we don't know that you want us to translate that into SQL. So we would just use the DB context DB set as a list. But we can tell our schema that we actually want to project into the database. And for that, we kind of can say, okay, we want to add a projections feature here. And we want to maybe add a filtering feature here. And we maybe want to add a sorting feature here. And I'm seeing we are tight on time, so I'm a bit squeezing now. Okay, so what we can do now here is we just added these features. Let me go back to the programs here. So we added these features just to our GraphQL server. So we essentially registered this projections feature here, and this filtering feature, and this sorting feature. And this allows us now here to use middlewares. So I can, for instance, say, first we need a paging middleware, because it's quite dangerous to just expose all the data in our database. And then we want maybe chain in, but also we want to use projection. And we haven't talked about that, but maybe I want to filter my stuff. And you have to be careful with that. That is by default exposing all the filter combinations you are possible on this type. But actually, in a real world application, we would make that much tighter in describing what filters are allowed on this query. Maybe you want to only allow simple lookups for grades or something like that. Okay, this is just demo code. We would make that actually more tighter in a real world application. Okay, and then we might say use sorting, and have now all our middleware on there, and could rerun our application. No. Yeah. So let's refresh the schema. So the first thing that we see here is that there's something wrong. And we actually can have a look here, and we can see that there is a student's connection now, not the students. And we can see that we have lots of arguments into our field, like first, after, last, before, and there's a where clause, and there's a sort, an order input. And then we can see that we have here actually nodes and edges and stuff like that. Okay, that's our paging structure. And let me just take that away and write this nodes field. The nodes essentially are our students. And this paging structure has this additional structure, so we can look a bit into maybe the paging info, which now exposes if the student has a next page or has a previous page and stuff like that. And that's why it's shifted a bit down. Okay, so essentially we can now get the same. If we execute that, you can see that we now get all of our data. And with projections, you can see that we don't have this simple SQL, what you saw before here. We actually project. And that means we create the SQL for your query. And we are doing that actually by rewriting the graph into expression trees. So if we asked only, and now let me just say this is our query, call this operation all. and create another operation here that just asks for the last name. Just to see the difference. Execute that. That's just the names. If we would look now into our SQL here, we can see we're just projecting the last name. So now we don't have overfetching in our backend because we are only fetching what the user requests. That's not said that you have to do your GraphQL implementations like that. If you have a proper design, like if you're building clean architecture applications, you can put that. You can essentially expose your business model that you have. You don't have to project like that. You can ask a GraphQL to tell you what fields you need to resolve and pass that into your business layer so that your business layer can deal with that problems. But if you just want to get a quick project with entity framework on it, it's very, very simple to do. Okay. Okay, so we've done that. But we also exposed all these filtering things. That means we actually can query into sorry, I have to drink something. We actually can query into this and ask for specific things. We could, for instance, ask for only the foo user. So we say we only want data where the last name is equals to foo. And then we just get foo and all the data to it. There's no next page because we found all foo data. Okay. So so far we have just dealt with queries here. We never looked at how do we mutate data. It's actually as easy as writing queries. So let's create a mutation to register a new student. So for this, we would create a mutation class. Just put that in the same file for demo purposes. In the mutation class, the same way we did write a resolver for our query type, we would do that for our mutation. In this instance, we maybe want to create a new student. And in GraphQL, you always return the changed state of the system. So if you mutate something, if you create new data, or you change data, you in the same instance would return the changed data or make it queryable so that the the user or the client, when it changes something, can read the change and update its internal stores in the client applications. Okay, so we would return in our mutation the student in this case and maybe call it register student. And to register the student, we would essentially need some data here, like the last name and the first name. Okay, that is what we want to have as an input. Also, we need a DB context to essentially create our entity and save that. Also, this is an async event in .NET. Let's call it async. Okay, very good. And with that, let's just quickly do it very simply here. Students, we're adding a new student. Quick and dirty. Do a student equals new student. Let me not bore you with typing here, but go quickly. Last name, first mid name. Okay, that's actually what we want. And then we also should maybe register an enrollment date, which is datetime.utc now. And then we can just plug that in here and return that. Okay, that that wouldn't work because we didn't save our stuff here. So let's save the changes. Wait, and actually we should ask also. So we can also ask. What you should have gotten by now is that we essentially can inject into our resolver, and the execution engine will resolve these dependencies. We also can ask the system for a cancellation token, which is the request aborted cancellation token of ASP.NET Core. So when the client would abort a request, we would get a signal here. So it's always good to just inject also the cancellation token here, and we are done. But there is a pattern in which we should do mutations, and that is essentially was defined originally by the relay specification and would require you to write a lot of boilerplate code. But we thought, okay, that's a very simple thing how you could write a mutation, and then if you wanted to have clean mutations without writing all this boilerplate code, you could just say use mutation convention. Add mutation conventions. And then we would look at the mutation type and just rewrite it to fulfill the spec. Okay, so we just say here add mutation. And then we're good to go. Our mutation should work. Let's run our stuff and see how GraphQL can mutate stuff. So instead of using the query keyword here, we're using the mutation keyword. Let's call that register. And actually, we need to refresh our schema here. Yeah, there's a schema update. And then we can say register student. And what you could now see here, let's go to the mutation type actually. Mutation type here, register student. You rewrote it, so you have a register student payload, which would be the thing we return, the student. And you also have this input with the first name and last name. So we rewrote the structure of your mutation so that it's more GraphQLified, and you don't have to write all these boilerplate types like input types and this register student input type and this register student payload type. So let's just say this is Luke. Actually, we don't need commas in GraphQL. You can write them, but the parser just throws them away. Anyway, Skywalker. And register him for a new course, and you can say we got the ID 4, and that's a cool thing. What we have now with exposing the data, because we can query actually for the ID that was created, and could now put that in our client store. Say, okay, we create the entity Skywalker, and it has the ID 4 because we can read the change state of our server. Okay, this is a GraphQL mutation. Let's go back to our slides. We are almost at the end. Okay, so these are the operations. And as I said, we have the query, which is a read operation. And it's side effect free read. GraphQL reading data means really, it's like you have a read-only model there. And you're not affecting the server state by reading. So you're not changing any data by reading. Whereas a mutation, you could compare it to the put, post, patch, delete in REST, and it changes the state.
Sorry,
of
Michael,
the
at least on my side, I cannot see any slide. It's just a black screen. I don't know if the viewers can see something. Oh, now it looks better. Fine, thanks.
Let me do it again.
Oh yeah, now it's fine. Yep, now it's fine.
Okay, sorry if you didn't see. So this is the operation table, just to explain how that compares to REST and from a logical standpoint. In GraphQL, you have a read operation, which is query, side effect free reads, will not change anything on your system. Whereas we have the write operation, which is a mutation, which is the put, post, patch, delete in REST. And this is actually where you change data on your system. Then we have something that you don't have in REST. I mean, there are technologies in REST that kind of allow real-time events, like you could have SignalR or stuff, but these are additional technologies. In GraphQL, that is built in. We call them subscriptions. It's also the last thing we will look at today. And they are essentially, you can subscribe to data. We will see that. It's really cool and makes this picture from GraphQL really nice. Okay. These are the three operations. This was actually the database demo. We did that. I should have gotten back to the slides, but anyway. Just to recap here, how does this projection stuff work? When we send in a GraphQL query like this, we will rewrite that to an expression tree, and the expression tree then is by entity framework rewritten into SQL that really projects the data that you want to consume. Logically, that works with a field middleware pipeline. So when we put these attributes on our field, and as I said, we also have a Fluent API where you don't have to use attributes, or a schema first API where you can use directives instead of these attributes. But it works the same way. Essentially, it translates into a field middleware pipeline where we have the use paging middleware and the use selections middleware or use projections middleware, use filtering middleware, and the use sortings middleware. And you can put any middleware from any custom middleware in between. It's essentially, if you think about ASP.NET Core, they have a similar approach to their request middlewares. So when the middleware pipeline is invoked, each middleware can do some stuff. In this instance, each middleware will just defer to the next middleware until it comes to the resolver. And the resolver will produce some data, in this case, a queryable. And then the middlewares will apply on top of this queryable filters, projections, and at the end, slice the data and execute it. That's essentially how that works. And you can put your own custom pipeline logic on top of that. Okay, as I said, there's one last thing that we should explore, and that's subscriptions. And that is a thing that, from a usage standpoint, works almost the same as query, but actually is completely different. Subscription, instead of returning a single result, will return us as a response stream. They call it in a spec. Essentially, we get a stream of query results, if you, to simplify that. So, yeah, that's what I already said. So a subscription does not work over HTTP. And in subscription, we have two components. We have events. Events in our system. So we have an events abstraction, and we call that in GraphQL the events stream. And to that event stream, we can subscribe with a certain subscription operation. And whenever this event is triggered, we will produce a response and send that to the client. Let's have a look at how that works. Let's first go here to our other demo that we did before with the cryptocurrencies, and have just a look at how that feels to consume a subscription. So with our subscription, with our cryptocurrency API, I could write essentially subscription. And then like a query, I could say, okay, I want to essentially subscribe to an on-price change. So every time a price changes, I actually want to know the symbol of the price that changed, for instance, Bitcoin and stuff like that. And I want to get the latest price. And then I could run this operation, and you can see at the moment nothing happens. I'm just subscribed. But when on this backend system, and now you can see the price changes and data comes in for the changed thing. But the coolest thing is here, actually it feels like a query, just a real-time query that changes whenever there's an internal event, a price change, whatever. And I not only can do like the simple things, I could actually drill into the data as well as what I did with a simple query. So, for instance, I can also get more asset information here. And then as soon as the events are coming in, I can see what prices are updated here. Let's see how we can implement that. It sounds complex. But actually, we did a lot of work to simplify how you can implement that internally. Okay, let's stop our server. That is the same server we left. It's our student server here. And what we want to build in is a simple subscription that where we can subscribe to a student whenever a student is registered. So the first thing is we need to introduce a new type that is called subscription. And it's the same like a mutation. And then we have to write a subscription resolver. And that is essentially written like our mutation resolver or query resolver. We do in this case we use a simple task to resolve a student, the student that was registered, and we call it on register student async. Let's go with this name. And also we need, like before, we need a DB context here that where we can grab the data from. But there is one more thing we need, and that is the ID of the student who registered. So we will just inject into our resolver an ID here, and it's a student ID. We also can call it student ID. Make it more clear. But this payload is not an argument, it's actually an event message. That is the event payload that we expect in order to be able to resolve this event. Okay, so when we get this event message, we will go to our DB context, get the students, just look them up where our student has the ID, then our student ID that we got passed in. And then we just expect that this really is there. It could get a lot more complex depending on what you're aiming to do. We just await that and return that. An async here and here. Okay. So this is a simple subscribe resolver. There's one more thing we need to do. Because this is a special resolver, we have to tell our system that this is a subscribe resolver. And we also have to tell the system that there is a topic. So we can put a topic in here. We could name the topic. Let's call it on-register students. We don't have to provide a name. If we don't provide a name, it's essentially the method name. And we also could provide dynamic topics that include maybe IDs that you get passed into your resolver and stuff like that. But let's keep it simple. So in this case, we just call the topic on-register student. And now there must be something that raises this event. This event could be raised by an external component. In this case, we will raise it through our mutation. So in our mutation, we will inject a topic event sender. And this is an interface that abstracts our internal event system, to say. So let's annotate that as a service that we will, annotate that as a service. This is an internal GraphQL service that we have, and we can interact with that. So we, in this case, will save our data, and after that, use our sender here to send a message on the event stream. And our topic here is on-register student, and we say student.id. And okay, we need a cancellation token if that goes wrong, or if the request is aborted, then we can just abort. Okay. With that, we actually have put everything together from our client side. This is subscription. We just need to register subscription as a feature on our GraphQL server again. And we also have to tell our GraphQL server what we use as an eventing system. An eventing system could be Redis. For our simple demo here, we use in-memory subscription system. And this underneath will use the threading channels of .NET. This is really for testing, or if you just have one single server instance, you don't have a lot of load. In general, I would suggest use Redis, which is a very simple pub/sub system, and most people just know it as a caching system, but it also has a very simple pub/sub system, and it's quite easy to deploy. And we have an integration into that. So use Redis in production, but for testing, you can use it in memory subscription system here. Okay, let's run that. Okay, so now we need two instances here. I need this application. So we see that that's really real time. Let's connect to our local system here. HTTP localhost 5000 GraphQL. And we are using the GraphQL WebSocket protocol. There are two protocols, the Apollo protocol, which is now legacy. And with the new version 13 server, we support the new protocol here. So we will use this one. You can still use either one with Hot Chocolate, but the newer one is more efficient. Okay, we use here the subscription, and actually, let's refresh the schema. One thing we forgot, right? Who gets it? What's wrong? We didn't register our subscription type. So we say add subscription. That's our subscription class, the class that represents that operation. And then we run that. We refresh here, and now we have our on-register student subscription here. We want maybe the ID and the first name. and we subscribe to that. Now the system is listening for new students to be registered. Okay, let's keep that here so we kind of see that. One thing. No. Options. Actually, okay. Doing something wrong here. Let's just put that here. Okay, actually, you can snap them like in Windows, but I'm somehow clicking the wrong button. Okay. So here we are waiting for our event, and here we could register a new student. Let's make a new name. This is, I don't know, Luke 1. Not very good names here. Anyway, we're just registering Luke 1. We are putting that in, and it should actually already been here, but there's something went wrong. Why? Let's try it again. No, this one. Okay, let's have a look. Add in mem. Sorry guys. So we have add in memory subscription. Let's look at the subscription type. This is our topic. This is our ID. We're subscribing here to our event message. On register async. That is a pity. Sometimes these demos go wrong. Just check. That all looks good. Go here. Let's debug that quickly. I'm sure that this doesn't run. If it doesn't work, trust me, it usually works. Okay, so we use that. Let me just subscribe here. Could be also my preview bit that I took. Okay, we get here. So the event is sent. Event message. Okay, but we don't get that. Why not? Add in memory subscriptions. So we could make that more complex to see what the issue is. But anyway, I think it could be the newest version. It's a preview that I messed it up again. But this is usually how you would build a subscription. There are more complex ways to do a subscription where you actually can access the stream and stuff. But this is actually the most simple way to do it. Okay, let's move on. This actually is the end of my presentation. As I said, the first time in this new format, so there were still hiccups. You can go to GitHub Chili Cream Hot Chocolate. That is our repository. We have there the hot chocolate server and also the strawberry shake as a client version of for .NET, where you can build Blazor applications that consume GraphQL. If you like what we do, give us a star on GitHub. This is really what makes this project more public to others and helps us grow. And with that, we can do some Q&A if you want to.
Yep, let's go for Q&A. So there's still plenty of you in the stream. So please ask your questions if you still didn't, and we can go through the questions which are asked already. And also, Michael, I have a couple of them for you. Anyhow, one thing I have to say, it's a shame you didn't do this before, but there was a time a couple of years ago when we were choosing between OData and GraphQL, and the only reason we didn't go for GraphQL was because there was no usable support for building servers and .NET at the time, and OData had a pretty something similar what you show, like more or less for fetching data from SQL and SQL Core, but at the end it turned out to be quite a cumbersome decision. More on that later. Let's see the questions we have already. Let's start with a simple one. If you have the link to the demos, I guess I don't know if they are in the repository of the project. Like, do you have examples there? Maybe you can just paste it in the comment field, and also I'll publish it on Meetup and YouTube also in the description.
Yeah, I will pass you I checked in now. It's on GitHub. There is a public speaking repository. I can give you that.
Yeah, you can paste it now, or if not, to everyone, I'll paste it on both Meetup groups and also on YouTube afterwards. Yeah. Good.
I can
to go to as a maybe introduction to one of the questions here. Demo was great, but like in real life scenarios, one of the first things that come is the authentication in general. So how this works with GraphQL out of the experience, so like OpenID and this kind of stuff. So what kind of authentication possibilities we have, how this integrates?
So GraphQL as per se is transport agnostic. And that means it has no knowledge. So there are two aspects GraphQL doesn't care about. That's authentication and also transport. And that's because that is all handled by ASP.NET Core. So everything that you can do with ASP.NET Core works with GraphQL. Essentially, what we do in GraphQL is handle things about authorization. That means you already get from the ASP.NET Core middlewares. There's a youth authentication middleware and stuff. You get an authenticated claims. So, and we use that then, this claims principle, to authorize. But actually, we also don't have implemented a new authorization system. We are using the authorization policies from ASP.NET Core. So this is all a concern that ASP.NET Core already solved. Okay, so everything that works there works with us.
Yeah. Maybe it's now a bit more advanced question to that, and it also comes to the topic you mentioned. So putting the GraphQL as a kind of a proxy behind already existing things. So this situation is quite interesting. Thanks for asking the question. So there are already OData endpoints. Good luck with them. And we want to put a single GraphQL. It's interesting, I think, in general. I'm also interested maybe to extend the question a bit out of your experience, a consulting experience. By the way, Michael does consulting for all this, in case you were interested in general in adopting GraphQL in your projects and companies. But did you ever seen anything similar? And in general, now comes the question of handling authentication across multiple APIs.
Okay, so authentication across multiple APIs. That also really depends. What you can do is, like, if you do GraphQL, you could do header propagation, where essentially the GraphQL server would propagate the headers to a downstream service like OData or like REST or like gRPC. And they would handle then the authentication and return the data if it's allowed. And the GraphQL server would just pass that through, maybe do some transformations on it. But the authentication could be handled down in one of those downstream services. They could also be handled in the GraphQL layer, where you annotate your schema with authorization policies. Essentially, you would use directives, which kind of, you could say, are like attributes in .NET, where you annotate certain parts of your schema and say, okay, in this part of the schema for this type, I want to use this authorization policy in my server. and then we would authenticate and only do the downstream call if you have an authorization to access this particular spot of data. But this all depends. There's a variety of problems that this could have. There are a variety of approaches that you could go down there. But as I said, everything that works in ASP.NET Core will work here because we are sitting on top of ASP.NET Core.
Okay, that's definitely a cool thing, like this smooth integration on the ASP.NET Core, so the things we learned already work. I hope this roughly at least answers the question. Answers the question. And also, but it calls for one more, if I may. So you already said now, like different situation call for different things, which is actually brings us to the question of best practices in general. Do you have the things documented? For example, during the talk, you mentioned we can do it this way, but it's easier to do it that way, or there is a more complex or less complex things to do something. I don't know to which extent is it documented on Hot Chocolate or in general on GraphQL. So when it comes to best practices, GraphQL is mature enough, I think, to have this overall best practices. Do you have also something specific for Hot Chocolate?
So we in general follow the Facebook guidelines or the Relay guidelines as best practices. There's a good book actually written by Marc André. Marc André is a former Shopify and former GitHub employee and now works at Netflix. So he worked at all the early GraphQL companies that are out there. Shopify is very invested in GraphQL. GitHub, as you see in the GitHub API version 4, is the GraphQL API. And internally, they are having a much bigger GraphQL API, which serves up the GitHub webpage. So he has a lot of knowledge in GraphQL schema best practices, and he has a good book which is called Production Ready GraphQL. And he essentially lays out these rules in a much wider way. So if you're interested to drill a bit deeper into that, learn a bit about that, Production Ready GraphQL is a good book to look for. And we follow these guidelines. That's I think when I showed you that we use that we add these mutation conventions. These mutation conventions essentially apply by convention these rules to your system. So you can write normal .NET code, and we will apply a lot of these best practices on top, schema-wise. But still, you don't have to use them. And there are some people, especially as they begin, that sometimes oppose them because they feel strange. They add certain terms like nodes, like edges to your graph. But as you go deeper into GraphQL, they adopt them anyway. So I would just suggest follow the relay rules, because that is the common best practices in GraphQL for schema design. And there are a couple of other GraphQL best practices for user errors, for domain errors, and stuff like that. And we actually teach them in our workshops. We are building that new workshop at the moment. Usually we would send users to a workshop project to explore these best practices, and we have these guides there. But at the moment we are in a transition to a new workshop. So I hope with the release of version 13, we again have this nice demo project where you can explore these best practices. Yes.
Okay, thanks. So the short answer is yes, the best practices are there, so they're worth exploring. Yeah. I wrote the name of the book and just pasted it in the chat so that everybody can see. Thanks. Yeah. To that, maybe while we are still on the topic of this downstream and everything, this is a bit advanced topic, I guess, from those already using GraphQL, but it's somehow related to the previous one. So in this case, we have multiple Hot Chocolate already gateways, and we want to put is this like putting a GraphQL above GraphQL?
Okay, so it's possible to fill it. Yeah, so Hot Chocolate is one of the first GraphQL implementations that actually implemented something that initially was that. So we were one of the first implementations with Apollo that implemented a distributed GraphQL system that dealt with schema stitching, federation. We also support Apollo Federation, as well as our own approach towards a federation. So there is, there's support for that.
Okay, good. I guess
that is for people that don't know. So what are these distributed schemas? GraphQL schemas can become huge. Like Facebook, for instance, they have over 10,000 types, and that means over 300,000 fields. It could be even bigger. Look at, for instance, the Microsoft Graph. It's an OData project. So Microsoft also, because they started actually before GraphQL became really popular, they wanted to expose the graph, so they started with OData. And they also, this Office graph, or this Microsoft Graph, is now huge. And what would you do in GraphQL? You actually would chop it up in subgraphs that would deal with certain concerns, for instance, with accounts, maybe with Office files or stuff like that. And then there is a gateway that would merge these graphs into one GraphQL schema. That is what we are talking about.
Cool. Pretty mighty. And maybe I can like provoke with this question. Like if you list all of this let's say benefits and so on, and the problem GraphQL solves, somehow this question pops up naturally. Why is there still REST? Yeah, honestly, people are asking this question regardless of GraphQL, like why there is still REST. But maybe to concentrate on the first one, what is a disadvantage? Or maybe if I can add on top of it, why isn't that widespread as it might be? Or maybe also, how do you see the acceptance of GraphQL in general in .NET community or in projects? You mentioned these big companies jumping on it and really employing it. So what is your experience in general for .NET? Because REST you will see everywhere, literally.
Yeah, but let's look at the big companies. Facebook, GraphQL, they invented this. Netflix, GraphQL. Twitter, GraphQL. New York Times, GraphQL. GitHub, GraphQL. Shopify, GraphQL. So none of the big companies are actually using REST to build their endpoints anymore. Microsoft Teams, GraphQL. Microsoft Office, GraphQL. Most people don't know that, but they're moving toward that. And Microsoft pushing on GraphQL, and I think you will see that in a couple of weeks. You will see that even more.
Are you talking about Build or
no? I'm not.
The conference. The conference.
But
some surprising there you're aware of.
They are pushing a lot of things into that stream, and they. You can see that also now. There's API management is in beta now. It's bringing a GraphQL support. So you see GraphQL is moving all the way into the .NET stack. So as we see, there's more and more GraphQL support going into Microsoft, and Microsoft is also going this way. The .NET community is a bit lagging behind that. If you go to the JavaScript community, to the Java community, you see a lot more GraphQL there. Like in JavaScript, I think every front-end developer will expect that there will be a GraphQL endpoint. And you see also the valuation of the startups like Apollo. They just in the last seeding round, they got 130 million just to expand their business on GraphQL.
Maybe you could just say a word or two for those who are not aware of what Apollo is, the company, and why it was important on this overall GraphQL scene.
Oh, Apollo is essentially one of the big players in the JavaScript realm of GraphQL. So they were one of the first companies producing tools and stuff for GraphQL. And if you are in the JavaScript realm, you might have touch-based with Apollo instead of with us. Where we are in .NET, they are in the ones in the GraphQL community, and they are really big. They are really big. So you can see that in other ecosystems it's much bigger, whereas in .NET we are more
lagging behind somehow. But maybe to this particular part of the question, what is a disadvantage? Because out of the presentation looks like there are only advantages. What would you point out as a potential disadvantage? For example, for people still listening, plenty of them, I know that all of them have REST APIs. Some of them are introducing gRPC now for sure, and so on, which is Microsoft pushing pretty actively in the community. And so in a productive application, let's say,
so REST, so GraphQL is not a replacement for gRPC. So in fact, if you build larger applications with GraphQL, like let's look at Twitter, they're using Thrift instead of gRPC for their microservices. But then over these, they have a GraphQL layer. GraphQL is often of the compensation for these microservice layers. You have down there Thrift or gRPC, and over that you have actually GraphQL, and that really combines very well, because in gRPC you have these streams that you can translate into deferred streams or into the stream directives on GraphQL, and that really aligns well. So you would use gRPC for these lower layer services, and then GraphQL on the top to make it usable. And that's essentially what I showed later. So you can go GraphQL native, where you have a GraphQL layer, have essentially a thin layer over your application layer, or you can put it over something like gRPC or Thrift, and it works as well. So gRPC is good for this low-level communications, right? But it still has the problem of overfetching, and it still has like
the underfetching, overfetching is definitely still there.
Like these fixed services, it's not really well usable in these kinds of scenarios. Whereas GraphQL is easier to use for the front-end developer, easier to use for data scientists even, when they drill into the graph. And you don't have to know that you are actually using 5, 6, 7 gRPC services downstream, or just using GraphQL, but still you are using gRPC. So it's not an exclusion. So you're not excluding these other technologies by using GraphQL. It's more, maybe you have a lot of REST services. You put GraphQL over it. It's the first thing that you actually do in modern projects. You have your infrastructure there, and then over your existing infrastructure, over your existing data, you put GraphQL and make it easier accessible.
This is an interesting practical question, because as I said, we all have existing services. So maybe we could have an approach like this one, wrote our application REST, okay, clear, and then rewriting in GraphQL now. Sounds like a joyful thing to do, definitely, but what you're proposing is actually side by side, or putting it on top of it, or I guess there is a way to move from REST toward GraphQL, or really to stay side by side. So
maybe I can show.
What is your experience in general, like out of consultancy, to this like transition to GraphQL? Is it rewriting what's supposed to do, or putting on top of it, or next to it?
It's both. It's both, really. You have parts that you never want to migrate. You have parts that you maybe write as the new application, and people now say, well, it's actually easier to write the GraphQL server now than to write REST service. I mean, you saw how clean the classes were. You write .NET classes, you can just give us your application layer, and it becomes GraphQL. And that's even simpler than with REST applications, where you have to care about DTOs, have to reduce actually the data, your type complexity to fit in. You cannot deal with certain aspects of type constructs, and you don't have the problem. But you often have an existing infrastructure, and you don't want to rewrite it only to have the latest fancy technology. So you can just write a bit of schema logic on top of it. And
so you wanted to show something? Should I add your screen?
Yeah, my screen, and then
yep.
So this, as I said, we have this is big. This is actually the demo project that we are doing for with the asset prices that we are doing for our new workshop. It's not yet fully finished, but anyway. So as I said, I showed in the beginning this defer function where we can prioritize data, right? Because we have slow data, which is coming from a REST endpoint. And actually we have, is it this one? There's this data point, and this is actually coming from REST. So we get a JSON object in here, and then we just annotate. We say, okay, actually we have here a field ID, and this field ID comes from a JSON object here. Sometimes we have to do a little data massage for the JSON object. Sometimes we can just say, okay, there's a percentage change that's coming from a JSON, and we just type it. That's if we do it with code first. This approach is called code first. It's a fluent API. You actually can do it even more simplistic, because GraphQL has a great data definition language. So we could also just, and you can give just such a GraphQL file to us. You essentially type your REST data. For instance, I could say, okay, we have the asset price here, and our asset price maybe has an ID, which is a string, which is not nullable, and maybe we have the latest price, which is a float. And the float is also not nullable. And then we just use a directive. As I said, this is in a kind of an annotation, and we can say from JSON. And that's everything you do. And now when you do an HTTP call and get the JSON data in, we will put that against this shape, and it becomes GraphQL. This is essentially how you implement. And I have to say that is version 13, only in our new version. We simplified really integrating these other technologies much easier. So you don't even have to generate a client. You just have to do a call to your REST service, and we will type it with GraphQL, and we will handle it. And you could also auto type it. There are tools in the GraphQL community where you just put in an open API specification and get the types. But the reason why this is not the best approach, why I like to write actually the types, is that often the REST data is maybe not shaped as you want it. You want to slice it. You have JSON paths here to slice the data. So you don't want to have one-to-one typings. And that is also if you ask for disadvantages, and that's not really a disadvantage in GraphQL. In GraphQL, we spend a lot of time on the schema, because we want to create this one graph, this one source of truth. So creating this schema is one of the top work spots in GraphQL. Deciding how should my schema look like. And you also don't want, in GraphQL, we don't have a concept of versioning. It's actually, if you start with versioning, you have done something wrong with GraphQL. Because in GraphQL, we would more work like with .NET APIs. We would deprecate fields and introduce new fields. And we always want that the clients never break. Like, think about Facebook, for instance. They have maybe users, maybe in some lower income countries like Africa or India, which use pretty old devices, which not even get new application versions, like the Facebook app. Maybe they don't have the latest version because the device is so old, but they still want to serve these users. So you deprecate your APIs. In GraphQL, you would say maybe this field is deprecated, like in .NET, where you annotate obsolete, and then it still works for these old clients, but new clients shouldn't use that field anymore. So that's how you evolve APIs. You wouldn't introduce versions actually. Okay.
While we are on that, like in code, maybe a question which was asked when you were explaining that deferred execution. when the data is coming later on, and so there was a question if there is a way for the backend developer, means that those who define the GraphQL, to actually also annotate that and say this is something which executes slowly.
No. Yes.
No.
Yes. No. You can
No?
put. So you can put documentation in. So if we look at the schema here.
There was also a kind of an answer in the chat saying actually yes, by describing the field resolver,
Exactly.
whatever that is. Maybe you can
so you can see here these document. You can see here the documentation that is actually coming from your types. So if I, for instance, go in this node type, I could just put a documentation on here, and that will translate to a GraphQL documentation. So when I type that in, it would translate into being on the schema. So you can say this is an expensive field, but defer actually is meant differently. Like you could even defer as a front-end developer. You could just you maybe are not looking at slow parts. You are looking at you're telling the backend which data is important for you, even if that is fast data. And the backend is actually allowed by the spec to omit the defer. So if the backend thinks you're deferring data that are not expensive, because let's have a look at the example. So if we would defer, for instance, this field here, like we would do here an add defer on this field, and this would make no sense at all. Why? Because when we actually get the price object here, the price object will always have this field fulfilled. So deferring is just putting more strain on the system because we have to put another payload in here. So the specification allows the backend, so it suggests to the backend implementers to fulfill always the defer all the data. But in the case that this actually causes performance downgrade, or is not a good thing to do, then the backend just can't send down the data. That means the front-end developer actually can say, okay, this is the important data. I want to have this data immediately, and I can put these defer pointers in even if I don't need them.
By the way, is it also deferring? Is it supported by Hot Chocolate, like on the server side? Do you have a support for that? Also,
yes, I mean, we were one of the first servers to implement. So
okay,
defer, just so people know. So defer is still a proposal for the GraphQL spec. We haven't merged that into the GraphQL spec yet. It will go probably in the next iteration, the 2023 iteration. We just have a new spec version, which was merged, I think, in October 21. And I think in the next specification version, it's defer will go in. There's another directive stream, which has a bit more work that we have to do on that, but it will also go in. But we are one of the implementations that essentially implement the features as one of the first implementers. There's a GraphQL reference implementation that implements them, and we are one of
you jump in. Congratulations.
Yeah, we actually sometimes have them earlier than the reference than the GraphQL JS reference implementation. For instance, we have now client-side nullability already implemented, and it was just merged as an experiment in the reference implementation. So we are one of the first platforms to have these features to prove that they work. And that's essentially how the spec process works. So the specification is written, the proposals are written, and then implementers have to pick them up and prove that they are implementable. And we are one of these implementations.
Congratulations, Juan, to that. This looks great. This also, I have to say, this definitely looks great. Maybe you can tell a bit more about the workshop. So not only if it's available on GitHub, so how do you do it? Is per invite, or is it where we can learn more about this?
We are teaming up with NEC for that. So we are at NEC Porto, NEC Copenhagen, or NEC Oslo.
London, I guess.
Yeah, but the workshop is not ready for London. We're still working. So originally London, the NEC London was scheduled for January, where we didn't feel we have it ready. It was moved because of COVID now to May, so we could have done it actually. But we're starting in NEC Porto with the workshops, the new one. We had the old one, which we did at the later NEC. So NEC is a cheap way to get into these workshops. You can also for companies hire us. But then you have to have a couple of participants that we come.
Yeah. Okay, so the feedback was on the chat. Fair enough. So that's good. But anyhow, but is it on GitHub, or is it the materials, workshop materials are
no, it
for
will
workshop
be,
participants only? Yeah.
It will be on GitHub. So you can also do. Great. So there will be a Docusaurus page where you have all the guides. You will not have us talking about and giving you the insights, but there will be guides to do all the exercises. And we actually have the old workshop. It's for version 11, but we have evolved so much after that I'm not pushing people towards the old one. But we usually have it as a free version on GitHub, where you can do it yourself. Essentially read through the instructions and do it yourself.
Yeah. Great, thanks. Let's maybe start closing a bit. Thank you everyone for asking the questions. If you still have some, please post it, and we will answer those final two questions. This one is interesting and goes across the lines we discussed already. So you mentioned these big companies going to it. So we have a public APIs to a larger audience and so on. But let's say for some internal software or B2B and so on one side there is a kind of an overhead, although I have to say out of this what you presented today, I see it as a minimal. So writing a controller in .NET for REST API looks more cumbersome than writing a GraphQL endpoint with if you have this standard, let's say, situation going to an entity framework database and fetching the data or something of business logic in between very nicely. But learning new technology and so on. So there is some extra work implementation wise for this internal software, not facing a large public and so on. Do you see GraphQL as a let's say first choice, or in which situations?
So if we just look at the .NET implementation that we do, it's the work. If you compare it to the work that you have to do for REST API, you have to actually do more work for the REST API. In any case, no matter what you do, you have to do more work for the REST API because it's really simpler to implement resolvers. And you expose a much richer surface to your users. But still, if you go in GraphQL, you will have like this initial learning curve, and that there is a learning curve to that. And if you want to build nice GraphQL APIs, you have to invest a bit in your schema design. But if you have already invested in your application layer, you actually done that work. Depends on how you approach these situations. You can also just hook, like I did in Entity Framework on there, and expose your database and be done with it, and that's your schema design. It's one approach, and it might be sufficient for some people, and then you don't bother with all the schema design. But if you want to really have something evolvable, you will invest into schema design. So why would I suggest that also for internal projects? Is that it's not only the bandwidth improvement that you have with GraphQL, it's also this mental model, how you interact with your data. So you're not limiting yourself. Actually, think about this. You're building this REST endpoint, and you're building your front-end application. Every time you have new use cases, new stuff to implement, or you need one more field, you have to actually change your REST endpoint. You have a much higher iteration between backend and frontend. Even if you are one person that does it, you always have to change your backend to change your frontend. Whereas with GraphQL, you expose your application model, and then you use that in GraphQL. That said, there are things that in an internal project that might not even be a problem, but there are things that you have to think about GraphQL also that makes it more complex, because in GraphQL you have a monolith that is distributed through the backend, that you can distribute on multiple downstream servers, but you have to also think about if you put it on a public API like GitHub, you don't just want people to query all kinds of data in all facets. Yeah, you want to introduce some restrictions. Maybe restrict how many fields a user can query at one time, or how complex a query can be. And Hot Chocolate has hooks into that. So you can say, okay, the max query depth is allowed to be 5. That means you can go 5 layers deep, or the max complexity is 1000. That is essentially the weight of the query. But these are things that you have to think about. Maybe not for an internal project, but if you ask for more complexity, that is the things you have to look at, which could be more complex. But I personally would go nowadays with GraphQL, but I'm a bit biased.
Like GraphQL. So yeah, this is the being biased, we understand, but what you're saying is GraphQL first. Interesting. One thing which goes with this question, which we didn't discuss. So we were discussing the server part, which is the difficult part there. But for example, for internal software and so on, like especially if we have a .NET client on one side, and if we have a .NET the server on the other side, we didn't discuss the clients. So how good is support in .NET world for GraphQL clients? So if I want to write a REST client, there are plenty of very easy ways to do it in .NET. What about GraphQL clients in .NET?
So we have a client that is called Strawberry Shake. It's younger than the backend. So the backend we are doing for years, whereas Strawberry Shake, I would say we do since Blazor came out, because to cater for Blazor. And we are adapting all the approaches that we essentially have in the JavaScript realm, which are still light years ahead of what we do. But we have a reactive approach. We have introduced store concepts and stuff like that. So there's Strawberry Shake, which gets a huge update with version 13. Because we built on the very first source generators, now we moved to a newer implementation, which allows for much faster build times and stuff like that. So there is support for that, and it's really getting better and better. And I would say you can do more than you can do with your REST clients, because these clients are reactives. They have a store. But again, there's a complexity to learn that actually, because as a .NET developer, you are often approaching this as a simple HTTP client, where in GraphQL, we in most cases would actually have a store, that a client-side store, where we know what entities we have in our in-memory representation. That's a whole different story. So it would be a whole different talk to
talk
look
about the
into
clients.
that.
But again, the short answer is yes, there is a support.
Is.
Just great, because it wasn't mentioned in the talk, and in general for consuming GraphQL from .NET, it's also important. But great, there is a talk. By the way, a side question. So we have a strawberry shake, we have a banana cake, and hot chocolate. What was the initial motivation for the names? I can imagine this. Like couple of you sitting somewhere in Zurich one evening, drinking something, of course, beer, and saying, "Yeah, let's start this stuff. How are we gonna call it?" So, what was the decision for going for this?
So the project actually was started by me and my brother. My brother and I, we actually through our whole life worked at the same companies, like twins, but he's actually my younger brother. And my son used to, when we used to go to Starbucks, and we are very, very often at Starbucks, very good customers of Starbucks. And my son would always go in there and want a hot chocolate. And when we thought about the name and we were spitballing ideas about the name, actually, if you go into our repository, look at the first commits, you will see that the code name was called Zeus, like the Greek god in the beginning. Because we didn't have a name, but we were spitballing ideas, and we didn't want to name it something like nGraphQL. I mean, GraphQL.net was taken, but we didn't want to go for nGraphQL or something like that, because these are generic names. But we always liked what we have in JavaScript, where we have, for instance, Gulp as a build system with nice icons. There's in Python, we have Strawberry GraphQL and stuff like that. So I like these creative names. And my brother, when we were in Starbucks, just said, when my son again wanted to order hot chocolate, he said, let's just call it hot chocolate.
Hot chocolate, yeah. Okay.
And from there on, the naming scheme was set. So each of our names represents a Starbucks drink or a Starbucks food.
To that, and also just to make sure developers are perpetually hungry. So this is a bit of feedback to the topic. It's a good one. Thanks to Logical Elaborate. We have, if you're in the mood, we still have a couple of questions actually, and pretty people watching us still. So let's go this. Maybe to this what we discussed on the UI requirements, which you said, yes, it's true. And you said you mentioned, like, for the internal projects, you said, like, maybe it's not that of an issue. I have to change the front end, so I'll change the back end. On a project we worked on, which could be considered an internal project, like for maybe like biggest customers, Ben is also working. This communication turned out to be to take quite some time, literally, because the skills were separated. It was always like two-person needed, to sit and talk and explain, doing changes on both sides. Then it wasn't a monorepo, so actually back and front end, they were actually in two different repositories. Which wasn't the best idea, it turned out. Anyhow, literally, like extending the REST API for back and for front end, it was cumbersome. And this is definitely for a new UI requirement. Assuming that the model already has it, there is no need for additional communication. That's definitely true. And one thing where I can also say, as a user of GraphQL, it's hard to go back after working with GraphQL. My only experience, like literally, like only experience with GraphQL was GitHub API, where I was developing a GitHub client originally with REST API. And that was like overfetching and underfetching only, like for literally to get the data I needed. For my particular use case, it was like 5, 6, 7, 8 calls, all of them very heavy, because in one of them I had this piece of information, another one this and that. And then I stumbled up on like by chance seeing, oh, GitHub has GraphQL, and all that story became that little simple, like GraphQL query. And once this, I have to say also to all the developers, once when you experience that, like there is no way back, definitely.
Yeah, that's really typical. How you experience. There was Immo Landwehr, who is a PM in the .NET team, and they wrote tooling for the GitHub API to do tagging and stuff like that when they do a release. And they did it on the REST API, and all the process took like 6 hours to run. And he tweeted that he switched to GraphQL, and he made it a bit sarcastic. So he said, we moved to GraphQL GitHub API, and we have a little optimization from 6 hours to 2 minutes. And that's because of the overfetching and stuff like that. And this is such a script you run on your desktop. You have maybe very good internet connections, and but still you have these gains. And often, as I said, behind these GraphQL APIs are the same REST APIs that you use as a user, but you don't have to push the data down. The GraphQL server is very close to your REST APIs, gRPC APIs, database. It's very close. Maybe if you're on Azure, same resource group. If it's on-prem, same network. So you have very low latencies between that. That's why I say overfetching between these components is not the expensive stuff. But sending that through the internet to somewhere else, that's where
that's costly.
feel it.
Yeah. Mm-hmm. Especially, if you have to fetch a couple of times and so on with overfetching, definitely. One more just practical question. You said already for the things like, like streaming videos and so on, it's not what we're going to use it for, but this is interesting question. Like JSON responses, or what if I want to download a file? Is it possible?
Download a file. So first off, it's not limited to JSON. We know GraphQL is transport agnostic. So internally in the GraphQL server, you're producing actually a result map, which is an ordered dictionary, which is the GraphQL result at the end of the processing. And this essentially is then serialized into anything. So you could use protobuf as an alternative to JSON. And with Hot Chocolate, you would essentially implement a serializer for that. We have not done that because there was not a request for this yet, but it could be easily done to have a protobuf serializer in front of that. Yeah, so you could use other things.
And to file downloading?
File downloading. So file downloading is not a GraphQL concern per se. You could do something. GraphQL has a multi-part response where you chain in the files as a result. But in general, uploading a file via GraphQL, there's a specification for that, the GraphQL multi-part request specification, which works nice. But downloading a file, that is something I would just do via REST endpoint where you have the file.
Separate API. Yeah.
Yeah, because that's where REST actually is good. You have a file structure, you download just this file. It's much faster. And also you have the benefits of CDNs and stuff like that, where your file could be located.
Good, thanks. Just for you, I don't know if you have a talk already prepared for the client part, like focus on Strawberry Shake. Maybe you have, maybe you don't. I saw you have a talk about Blazor actually, like using GraphQL and Blazor application. I guess that's the Strawberry Shake one. It's an interesting combination, like Blazor and then Strawberry Shake. Yeah, maybe some at that.
I'm working with Microsoft's Brandon Minnick to have a workshop on Maui. We hope we have that ready later this year, and then we have more content also not on Blazor specific, because there's also a lot of demand for Maui clients. So that you can see how to do it. I mean, it's possible you can use Maui and GraphQL together with Strawberry Shake, it will work. But we are working to get some content out there that also describes these situations.
Good. Yeah. So let's see. And the interest for this talk was high. So maybe it would be great to have you somewhere down the road again for the client side. Let's say when you
Yeah, sure.
answer that. Great. Here is the one. Here's the one. Thank you. Quick thanks, but for many also. I think thanks everyone for staying with us for so long. Definitely. There is just one question more, which I'm not sure if I understood it, but maybe it will ring some bells at your side, Michael. So. Enforcing service workflow commonly used in conjunction with GraphQL. But still, let's tackle this topic as well.
Depends on if you mean something like a schema registry or something like that. We are working on tooling to have these kinds where you can store your persistent queries, where you have a schema registry that keeps track that you don't break APIs and stuff that integrate in your DevOps system. We're working on that, and we hope to have that with the version 13 cycle out. If that is what you mean,
Yeah.
it's a bit unclear.
It was for me also. I can imagine different things behind the question, but still, this what you mentioned is also interesting to know. Definitely. Good then. If there are no any other questions, I would say thank you, Michael. First of all, and congratulations for the great job. Like on hot chocolate, it's impressive, definitely. As I said, it's a pity that you didn't do it a couple of years earlier, but okay. This talking to your brother in Starbucks, but anyhow, thank you everyone for staying with us. The talk is recorded and it will be available on YouTube. Yeah, like kind of forever. So that would be it. And things we will stop now. Yeah.
Awesome.
Thanks everyone. Bye.
Goodbye.
Bye.